Construction and building materials. Influence of waste glass power using the properties of alkali-activated slag mortars based on response surface methodology by Valentina Ospina. Effect of waste glass power as a cementitious material. Potential material on the strength. The drying, sulfate attack resistance of slag mortar activator. Introduction. The objective of this work was to study the feasibility of incorporating waste glass power as a potential cementitious material in combination with slag to develop new binders, activated with water glass. Materials and experimentations. Materials. Commercially available slag, glass power, ordinary Portland cement, water glass, silicate, sodium hydroxide, crushed limestone sand. Mixed proportions and processing. Response surface methodology, RSM. RSM is useful for modeling and analyzing the problems in which a response of interest is influenced by several input variables with the objective of optimizing the response. In AAS cement, the alkali content in activator has large influence of mechanical properties, which finally affect shrinkage. Table 1. Chemical compositions of slag, glass power, and OPC. Mixed proportions. In order to obtain the desirable workability and ability to make the comparisons, the binder aggregate ratio and water binder ratio for all the mix were fixed at 1, 3, and 0, 4, respectively. Test methods. The flexural and compressive strength tests of the specimens were conducted according to China National Standard, GB/T. Drying shrinkage test. The specimens were placed in laboratory conditions, 20 Celsius and 55% air ash. The length change of specimens was recorded periodically up to 120 days. The test results shown are the average values of two specimens. Resistance to sulfate attack. After 28 days of curing, the prismatic specimens were immersed in water and in two solutions, one containing 5% sodium sulfate and the other 5% magnesium sulfate, for up to 90 days. The flexural and compressive strength of the specimens were measured to find a strength reduction. Results and discussions. Response surface analysis for strength. Analysis of response surface models. The strength of the 13 samples are shown in Table 4. Optimizations. Multi-objective optimizations problem is also called multi-criteria optimizations problem, which is composed of a set of objective and associated constraint functions. Drying shrinkage. Drying shrinkage of OPC, AAS, and AASGP mortars versus time are shown in Figure for up to 120 days. Sulfate attack. Data on strength reductions of OPC, AAS, and AASGP mortar optimized mixture. Conclusions. Some conclusions. Reference. Thanks.